Welcome to the Crazy Hat Chemist. So today we're doing the 9th video in a series of 23, but this is on nuclear chemistry here, folks. So let's get started. Bam! So, nuclear decay equation. So what I want you to do is I want you to review a couple of videos that I've done previously, and they're talking about the types of nuclear decay or emission. So alpha, beta, gamma, positron, etc. So take a look at those videos first. I want you also to pull out a periodic table because you can't do these without having a periodic table. All right, so let's get started with the first one. So we're going to write an equation for the loss of an alpha particle from the nucleotide of platinum-194. So this is why you need your periodic table for yourself. So you're going to find your periodic table and you're going to look up the atomic mass of about 194. Around in that ballpark, you should find platinum. That's PT. Then from that periodic table and that mass, you're going to find the atomic number for platinum so that you're going to come up with what the notation, the correct notation is for platinum-194. This is the correct notation for platinum-194. It is the atomic number of 78, that's the Z. The A, the atomic mass, is the 194, and PT is the symbolic notation. That's the AXZ format that we have been following before. Okay, so now you're going to read the question again, and this is going to have the loss of an alpha particle. So do you see that we only have one thing on the reactant side that's critical? So we're going to lose an alpha particle. So that's why you needed to review that lecture on alpha particles. So you're going to write down what the alpha particle is, its symbol, its mass, and its charge. And this is it. It's a 4, 2 for the alpha particle. 4 is the mass, 2 is the charge, and the alpha symbol there. Okay, so now what you're going to do is you're going to do the math associated with it. So it's 194 is equal to 4 plus what number? Okay, and then also the rest of the math is 78 is equal to 2 plus what number? And then that what number that we get there in the denominator of these here is you're gonna look on your periodic table and you're gonna find what element is correlated to 76. 76 will tell you what element and what symbol notation you're going to be using. So hopefully this worked out well for you, and that's osmium-190. Okay, so all alpha particle emissions follow this same pattern here. You got to figure out what you start off with, write down the alpha particle, do the simple math that's associated with it. It's just arithmetic. So let's do another one here. What nucleotide is formed when radium-228 loses a beta particle from its nucleus? So what we're going to do is we're going to find radium-228. Again, you're going to look on your periodic table. You're going to write the symbol for radium-228. You're going to find out what the atomic number is for radium based on that. 228 will give you a ballpark of where to look for on the periodic table. And radium is 88 on the periodic table. That's atomic number 88. Okay, it has a mass of 228. Okay, now this is going to lose a beta particle, so you need to write down the symbol for the beta particle, and that is the symbol for the beta particle. It has no mass, that's the A in the numerator, but it has a charge of -1, and there's the beta symbol. Okay, so 228 is equal to 0 plus what number? 228. So the numerator term, the mass of my next particle that I get here is 228. And then 88 is equal to -1 plus what number? So we're effectively adding a number here. So it's going to be 89. So you're going to look up 89 on your periodic table, find out what element that corresponds to symbolically, and then write that down here. So that's why we have AC 228. That's atomic number 89. Hopefully that worked out well for you. Okay, so let's do a few more because we've only done alpha and beta so far. We need to do gamma. So what nucleotide will be formed when radon-222 emits a gamma ray? So again, we're going to find radon from the periodic table using the mass of 222. Now again, it might not exactly correlate with what's on the periodic table because this is a specific isotope. Okay, and it is a whole number isotope. It's not the average mass of the isotopes that are on the periodic table, so that's okay. So we're going to find radon 222 on the periodic table. It has an atomic number of 86. Now we're going to write the symbol for a gamma ray. Okay, and this is the symbol for a gamma ray. It has no mass, it has no charge. So you should see 222 is equal to 0 plus what number? 222. 86 is equal to 0 plus what number? 86. So you already know radon already. So you're going to write that symbolic notation. And again, just to refresh your memory, if you don't remember, but the alpha, the beta, and the gamma particles. The gamma rays emits a light or a photon, and it's decreasing the energy that is in that nucleus. So that's why the product is more stable than the reactant typically. Okay, so that's alpha, beta, gamma particle emission. Okay, now we're going to do another one here. So what nucleotide will be formed when carbon-11 undergoes electron capture? So there's a key word here on this problem, and it's capture. And that capture lets you know that it's on the reactant side, unlike the decays. Decays is breaking apart, like the alpha, the beta, the gamma, they're decaying, they're breaking apart. That's why they're on the product side. But this one here, we have a capture. So we have an electron. We already know what an electron symbolically is. We're going to write carbon-11. So we're going to find carbon on the periodic table, approximate mass of 11 here. It is 12 for the average mass. But this is going to be carbon-11. So we're going to write down carbon-11. Notice that I've included the plus sign because I actually need to write down the electron that's being captured here. So I'm going to write down the formula for an electron that's captured, and that's right there. That's an electron that's captured. Now what we're going to do is we're going to do the math associated with this. That's 11 plus 0, that's going to be 11, and then 6 plus negative 1, that's going to be what number? I hope we got that. Okay, and that's a 5. So now we're going to find 5 on the periodic table. That's boron, and this is atomic mass of 11. And there's a neutrino that's emitted as well on this one. Hopefully that worked out well for you. Okay, so let's keep on doing this. We are not done yet. What nucleotide will be formed when magnesium-23 undergoes positron emission? Again, it's emission again, so that's a key thing. So we're going to do magnesium. That's different than manganese. Magnesium-23. So we're going to find magnesium-23 on the periodic table. There's magnesium-23. Remember, this is an emission, so it's on the product side, unlike the capture that was on the reactant side. So we're going to write down the positron symbol. So this is like a beta particle. It's an electron, but it has a positive charge here. And that's why that positive charge right there. So 23 is equal to 0. 23 is equal to 0 plus what number? 23. 12 is equal to plus 1 and plus what number? Hopefully you got that here. That's going to be 11. So this is sodium 23. Okay? Hopefully that worked out well for you. So it's 23 is equal to 0 plus 23, right? 12 is equal to 1 plus what number? 11. Hopefully the math is like super simple. It's just arithmetic on these problems. Okay, we're going to do one more here. What nucleotide will be formed when lead-214 successively, that's in sequence, emits two beta particles and then one alpha particle from its nucleus? Okay, so we're going to do this in sequence. You could combine the two beta particles together, multiply it by 2, and that would be fine. I don't know if your professor or instructor will go for that, but that's one way of doing the math really simple, and then you got to do the alpha particle. But we're going to do this in sequence, in steps. So the first thing that we're going to do is we're going to find lead on the periodic table, has an approximate mass of 214, so we're going to find 214 on the periodic table. Hopefully you can find lead from that, and we're using a particular isotope of lead, that's lead-214. Okay, so there's lead-214 that we have there, and it's going to successively emit 2 beta particles and then an alpha particle. Notice that the lead is all by itself on the reactant side because it's an emission of particles. So we're going to write down 1 beta particle. That's 1 beta particle. Okay, we're not done yet. Now, we could write the product of this if you wanted to, but we're going to do this all jumped up together, and it's going to be really simple. Then we're going to write another beta particle. Okay, and now we're going to emit also an alpha particle as well. We're going to emit an alpha particle. So now I've taken care of all 3 emissions from this. And now what we're going to do is we're going to do the math so that we can come up with the product. Okay, and that is 214, that's in the numerator, is equal to 0 plus 4. Plus what number? So I'm looking for that what number. That what number is 210. Hopefully that worked out well for you. Okay, and then 82 is equal to -1 plus -1 plus 2 plus what number? That plus what number is going to be 82. So this is going to be another isotope of lead. And so this is the isotope of lead that we're dealing with, is 210. Okay, Hopefully that makes sense for you. Make sure that the numerator terms sum up and the denominator terms sum up. These are really simple problems. The most difficult part is that you obviously need a periodic table with you so that you can look up the atomic number for that particular element and write down the symbol. Okay? I am the Crazy Hat Chemist. I got a great hat here for you today. It's a basketball hat because we got the Sacramento Kings, baby. Give me a thumbs up if you like that video and subscribe to my YouTube channel, and I'll be shooting hoop with you next time.